In an increasingly volatile world, trade flows are shaped not just by economic fundamentals, but by geopolitical shocks and shifting alliances. Traditional gravity models, using macroeconomic factors like GDP and geographical distance, misses this dynamic. Our model fills that gap from the lens of a Singapore MPI trade analyst, forecasting how global shocks affect Singapore trade with its top 16 partners, which account for over 75% of national trade. We use temporal graph neural networks to model spatial and temporal dynamics. Modeling at the country pair level captures ripple effects like how US-China tensions might ripple into Singapore-Malaysia trade. While deploying a model to relate geopolitical distance with trade volume while incorporating sentiment scores, we built a hybrid index, combining FDIC structural data with real-time new sentiment. We benchmark this against the conventional metric of UN voting records using the same prescribed model from the research paper. From a news article, our model extracts sentiment scores to forecast sectoral bilateral trade volumes between country pairs. Now we'll dive into our NLP and TGNN model.
Our NLP model starts by scraping news articles with Shafila, providing text for pre-processing. The texts are tokenized and processed to predict sentiment scores between country pairs, capturing the nuanced aspects that affect trade dynamics. We use a fine-tuned model for aspect-based sentiment analysis to extract sentiment scores between country pairs based on specific geopolitical events. After fine-tuning, the NLP model performs well, evidenced by a low mean squared error. Now, looking at existing solutions, we have BBVA Research Geopolitics Monitor, which uses GDEL and Camille to track broader geopolitical risks. Upon comparison, our model is focused on trade-specific forecasting. Our model offers more granular insights into how geopolitical events between country pairs affect trade dynamics.
So how does the TGNN model tie into our workflow? It obtains a newly computed set of sentimental scores from the NLP model and overrides initial baseline ones between country pairs within the composite index to output forecasted sectoral bilateral trade volumes. You might be wondering how the model works. With many state-of-the-art variations of TGN models, we settle on AGCRN. Its key feature lies in the two modules used to enhance the traditional GCN layer, NAPL and DAG. These address the spatial dimensions of the trade data. These are paired with conventional gated recurrent units to effectively capture temporal aspects as well. Now, how does our model fare with current works? Recent research published by MDPI has explored applications of GNNs for modeling trade networks and benchmarked against other models such as random forests, showcasing that graph attention networks performs the best. Our model builds on this and includes self-attention mechanisms in learning complex relationships between each country pair, achieving satisfactory performance during the training validation stage.
Now that we've covered the model architecture, let's look at some of our limitations and feature sets. Sentiment analysis lacks sector granularity, and we train on mostly factual news sources. We'll map events to sectors and include opinion pieces to improve emotional detection. Geopolitical event progression isn't captured. Articles are treated as isolated events. We aim to model phases like tension, sanctions, and impact using topic modeling. Our geopolitical distance index built from FDIC index and sentiment scores is still experimental. More research needs to be done to ensure its comprehensiveness. Ultimately, our goal is to build not just a model, but a decision tool that evolves with the world, giving policymakers the foresight to navigate global uncertainty with confidence.